Well, welcome back guys, and I do hope you and your family are well. So what we're going to do today is I want to demonstrate a practical that you need to know about for GCSE, and it goes under the complicated title of current voltage characteristics of electrical components. So let me break that down into something a little bit simpler. What we need to do is take an electrical component. So here I've got our old friend, the fixed resistor. And what I want to do is I want to find out how turning up the voltage affects the current flowing through it. Okay, so the current voltage characteristics. So if you think about it, the equipment I need is fairly simple. I need something to provide a voltage, a potential difference. I can change that potential difference, that voltage, and as I change it, I'm going to measure with an ammeter the current through the fixed resistor. So what I'm going to do is set up the equipment, and seems a bit odd this, but kind of talk yourself through what you would do here. So I'm going to connect a voltmeter across my resistor to measure the voltage across it, the potential difference across it. Okay, so I'll bring all of that into shot. So here we go. So I've got my fixed resistor and a voltmeter across that. And then I need to provide some current to the setup. So here's the electricity coming from the battery going into the fixed resistor and then coming back. But I'm not going to go straight back to the battery. I need to measure the current coming back. So here's an ammeter, and I need one more wire. Okay, from the ammeter coming back to the battery. I'm looking at my screen to check I can see all of this. Okay, so it might look like a bit of a complicated arrangement, and obviously with these short lessons, I have to do this very quickly, but in class we'd obviously build it ourselves, and on a longer YouTube video I could obviously show this much more effectively. But just think of what we've done. Okay, I've got a simple circuit here, so I've got coming out of the battery through the ammeter, through the resistor and back, and then I'm measuring the potential difference across the fixed resistor. I'm going to turn it off because I don't want to flatten the batteries, and I don't want the fixed resistor to get hot. I'm not changing that variable as well. The only variable I'm going to change is voltage, potential difference, and I'm going to see how does increasing the potential difference, the voltage, affect how much current goes through a fixed resistor. So we're ready to go. I've drawn myself a little table here, and I'll put a photograph of that up. And it's pretty simple really. I'm measuring the potential difference with a voltmeter, and I'm measuring the current through the fixed resistor for different potential differences. So I've got my circuit here, and the trouble with circuits is they always look like snakes playing Twister, but don't worry too much about this. I'll just do a first reading, and I'm not reading off the battery. I'm actually using a voltmeter to read the potential difference. So I've got a potential difference of 1.43 volts. That's perhaps a little bit too high a precision, but 1.4 volts, and a current of 0.16 amps. Then I'll go to the next voltage, 2.79 volts, and a current of 0.30 amps. The next one, what have we got? 4.13 volts and 0.43 amps. And remember, I'm turning off so the resistor stays cool, because that could affect its resistance if it changed its temperature as well. Here's the final one, 5.40 volts and a current of 0.56 amps. So I'll take a picture of my table, and then it would be actually really good if you got yourself a sheet of graph paper and you graphed this. I'll show you what I want the graph to look like in a minute, and I'll show you the data that I've gathered. So let's do that now. Okay, so let's see if we can analyse the results we got. So we looked at how changing the potential difference on a fixed resistor affected the current flowing through it. So it might be a good time for me to just quickly sketch the sort of diagram we had. Let's make that a variable battery, a variable power supply, and then down we came through an ammeter in series with the fixed resistor, and then back to the battery. Okay, a bit difficult to see with all those wires on the bench. And then here we go, let's measure the potential difference in volts across the fixed resistor. So we can change the voltages and see what we get. We didn't do it, but we can actually turn the battery around and drive electricity the other way and check what happens when we pass amps backwards. In other words, we have a negative voltage. So I'm hoping you've plotted your graph now, and what you will have ended up with is something quite interesting. Hopefully, okay, remember what we knew was the potential difference, okay, the PD in volts, and we measured the current in amps. And when you plot this graph, you basically get a straight line. So yes, I'm not talking about errors and things now, but you basically get a straight line. If you turn the battery around, okay, you get this voltage negatively, and the current goes the other way, so you get a value here. You get a higher negative voltage and a higher negative current. So the bit that you didn't do, but is important for GCSE, is that if we do negative values, in other words, that's a negative value of voltage and that's a negative value of current, it's exactly as you'd expect. Okay, so I'll come over here. We get a line through the points. There it is. And you'll notice something about that line, that it doesn't wiggle about. It's a fixed gradient. And the gradient of that line tells us something about the resistance. Now, here is where it gets difficult. And a few bits of teaching where I kind of bang my head against the desk numerous times because I can't get it across, no matter what I try. Okay, so I'm going to give it a go here. Follow this through very carefully. Okay, if the line is like that, if I turn it this way, we're getting a lot more amps for the voltage we had. Okay, and if we get a lot more amps for the voltage we had, it's conducting better, so it's a lower resistance. Okay, confusing, isn't it? And if the graph is very flat like this, we're getting lots of volts and very few amps, so it's a high resistance. Okay, you got it? So low resistance, high resistance. Okay, you plug your ears now if you don't want this bit. This graph shows how well it conducts. Yeah, conducts badly, conducts well, conducts really well. But at GCSE, we always talk about resistance. Okay, so as the amps are less per volt, the resistance must be going up. So what I always do at this stage, which is usually precedes me banging my head on the desk, is I draw another line like that, and I ask students, okay, which one is the high resistance? And they invariably get it wrong. So think about it, lots of volts, very few amps. This one is the big resistance, and this one here is conducting better. It's a lower resistance, it's a smaller resistance. Okay. Now, there's one other thing I'd like you to do, and please do this. Take the numbers on your table, okay, and divide the voltage by the current. Okay, so find the potential difference column and divide it by the current column for every single reading across. Okay, now one or two of you will go, seen that before somewhere? it's not Ohm's law, but it's an equation we use when we're doing Ohm's law. Okay, resistance is equal to potential difference divided by current. Now, think about it. What does that mean in your table? As the volts went up, the current went up. As the volts went up more, the current went up more. There was a proportional relationship. In other words, if you divide the voltage by the current, you'll always get the same number here. So if you have, say, 1 volt, you'll have 1 amp, 2 volts, 2 amps, 3 volts, 3 amps. In other words, the resistance will remain the same. And if you do that on your table, okay, here's the spoiler. With the data that we got today, I'm pretty hopeful, if I pick the right fixed resistor, that you will get 10. And remember that the resistance is always measured in ohms. So, this is a fixed resistor. The ratio of potential difference to current, V over I, stays the same. Okay? And if it stays the same, we can say it obeys Ohm's law. It's ohmic. For any value of potential difference, if you divide it by the associated current, you'll always get the same number. It's a fixed resistor, it's ohmic. So, I hope you've now got a really good understanding of fixed resistors and the experiments we do with those. And at GCSE, it's this graph that you need to know. Okay, they'll put one line on it, I think, and they'll just say, mystery graph, guys. What electrical component is it? And you look at it and you go, it's a fixed resistor. It's got to be a fixed resistor. So what I'm going to do in the next couple of videos is I'm going to look at what happens with the LED, because that's a slightly unusual device. And before that, I'm going to look at another thing that has resistance. I'm going to look at the filament lamp. Anyway, hope you found that useful, and I look forward to seeing you again soon.